Good morning and good afternoon, everyone. Depending on where you are in the world, we're 1 minute late, so you might not be on time, but you definitely need to be in depth. Welcome and thank you for signing up to this webinar. I'm with my colleague Gaston, who will take over in a few minutes. My name is Arne Nordborg and I'm a Global Business Development Manager working for Segal. I hope you all are well, despite the very strange circumstances we have these days. This is a live webinar that will last for about 30 minutes, where in this case we will go into one of our patrol plugins called Rocks Velocity. We see, as I mentioned, that the business landscape is changing, and like we're sitting here together now, will maybe or most probably be a way that we have to get used to working in the future. That's why we put together these live webinars for Segal, and showing a little bit the importance of operations and performance working well. We think, partly at least, that we can increase productivity, flexibility, and also the scalability by talking to one another and getting used to this kind of collaboration as we see here today. And finally, we think that through processes like this, it will even improve the digital collaboration even more, getting used to, as I mentioned just now, this situation. There will be a possibility in GoToWebinar to ask questions. There's a certain chat opportunity, and what I suggest that during the presentation, if there are any questions, feel free to add them to the chat, and we can answer them at the end of the webinar. All the information or all this recording will also be shared through an email to all of the participants afterwards, and we will also share it through our YouTube channels, etc. A few words about Segal. Segal was established back in 2000 and focusing on, at that time, delivering a cloud solution. Through the last 20 years, we have developed quite extensively, becoming a company with 420 employees. And for this particular webinar, I like to focus on what happened in 2014, where the company called Blueback Reservoir was acquired by Segal. And we then moved from being a pure IT company into an IT company with the G&G domain experience, and not to forget also the software and the software understanding coming from the Blueback Reservoir side. We have then grown extensively over the last years, and I'm proud to say that both with our Blueback plugins and with our GeoCloud solution, we are an important partner to many companies in the oil and gas industry. We have a global footprint. We have offices in Calgary, Houston, and as you can see also in Asia now. That was the last office we opened in KL. And we have our data centers where we provide operations through our solutions in Stavanger, Amsterdam, Aberdeen, St. Petersburg, and Moscow. So we have an increasing international presence around the world in the main oil hubs. So what we think is important with the solution that we have within Segal is that we support the industry needs through having the domain experience, both when it comes to understanding the software side of things, which we will focus on today. We have a broad portfolio of software from the geology, geophysics into reservoir engineering and data management, covering the most important parts of the day-to-day workflow in the oil companies. We also have the consultancy. We have both standard consultancy through geoscience. We do software development for companies, special IP development for companies. We do data management, infrastructure, and also business consulting through advising and setting up different solutions from IT to software preferences, applications consulting through the different into different companies. Finally, our biggest business is the GeoCloud, which is our cloud solution for the oil and gas business, which is a scalable solution where you run IT environments through a specific cloud solution. And as mentioned, we have our domain experience all the way from the reservoir modeling through to the drilling. So that's a short intro to Segal. And with this, I leave the floor to my colleague Gaston, who will take over and talk about Rocks Velocity, which is the key presentation as of today. So Gaston, feel free to take over with your presentation.
Thank you, Stoffe. Good morning and good afternoon, everyone. Hope you listen to me well and have a good and clear signal. As Arne said, we are worldwide distributed, so I am broadcasting now from Germany. He is in Oslo and everyone else is somewhere in the world. This is possible to all these new technologies. So you might not be on time. Some of you may be still on the way from maybe someplace in your house or your home to the computer. But we all know as geoscientists, we need to be definitely in depth. Problem is that seismic is acquired in time, but we need to drill in depth, and geology is in depth. So we need to be able to domain convert this, and as simple as it might be at the beginning, this can be quite a tricky problem, as we all know. So we started with this app a couple of years ago, sponsored by an operator in the North Sea, and they wanted us to help them solve some common problems. And if you go and start, you want to build a velocity model, you know you have some issues to sort out, like lack of sonic calibrated check shot surveys. You may have good stacking or RMS velocities providing good coverage, but they lack precision. And obviously there is noise and lots of uncertainty. The major requirements for this tool for us was to make something simple, highly interactive, so that the interpreter is continuously visualizing and assessing the impact of the data whenever he or she derives any parameters. So you have the ability to look at your velocities all the time and then create with good confidence a geologically consistent velocity model. This is a display of the main workflow of the app. So we start obviously loading wells and if they are available seismic velocities into the application. There's visual QC, and then you go into several of the steps. At any time, well, you define the surfaces and the markers. At this point, I must say we use a standard method in the industry, which is called a layer cake approach. And we go from there. Lots of tables and the QC options. This is something very well received by our users, because looking at the data is really important in this case. Then there's a workflow to calibrate the seismic velocities with the well velocities. There is no need to build any 3D grid or do some complicated 3D model building activities in Petrel. You just do it in the app. Then you define your parameters for each of the layers that you have. But at the moment of you doing this, you visualize your velocity maps almost in real time if you want. So possibilities to add external interval velocity surfaces if you want, do some residual corrections, and then once finished, go to the output side and build your velocity model. We have added in the new release, in release 3, a new workflow based on detrending the seismic velocities. So with this, I believe it's better to go into demo time. So this is us in Segal with the cloud. We are somewhere, and we understand everyone is now at home and staying safe within their families and attending this presentation. So continue doing so, continue staying safe, and yeah, now we go into demo mode. This is a small project from the North Sea. We will have a few surfaces, and I also have created a intersection line where we're going to see our results. This is in the time domain now. So we have the usual setup, some wells, some of them are deviated, you have markers, you have some interpreted surfaces, and then the challenge is to depth convert this. There is also in this data set, we have some additional information, like we have lots of stacking velocities here, and they pose a special challenge. In this case, they are not regularly sampled, which is true. This is the way they came from processing. So I had to do a bit of massaging before on those. But one very handy application that helped me on this is, for example, the Blueback GDI Investigator. So I was able to define some interesting trends with that. So that's a bit of a staging the scene. So I will just go and show you some of the interfaces related to our app, and rush if you want through the workflow. There is no big time to do a detailed analysis on what Rocks Velocity can do, but we hope we can excite your appetite for more. So we are obviously, if you are interested, anytime for you to show you this into more detail, or even help you if you would like to use it and evaluate it for your prospects. So we have here the loaded data into the app. When I say loaded, it's basically declaring everything. We are inside Petrel. We're completely integrated. So everything you have in the Petrel tree, everything you need, it's just available inside the application. So every well that has some sort of time depth relationship in Petrel qualifies to participate in the process of building a velocity model, which is in this case all these wells. Then I have also added the stacking velocities that I was showing to you here into the panel of the Rocks Velocity app. And so now I have all these velocity points, plus in green you see all the wells. So it's easy to now have a display like this, all integrated. In yellow you see the seismic velocities, in green all the wells. So wherever I can go and check. I do have some problems here, as you see immediately. So a very high velocity. So this we can deal with that later and see. But right away you have here a very nice way to do some good QC. If you would like to go and check this well specifically in Petrel, you click on this button here, and it just takes you right away where this well is, so you can go and investigate further and maybe do some decisions about, for example, these calibrated check shots, if it's correct, or if you would like to maybe look in detail at this far too high velocity point. Next, You go into the definition of the surfaces, where you define here your input surfaces, and correspondingly you define your markers. Uh, I was talking about these tables for QC. These are really valuable tools. Here you have a lot of information telling you at the beginning already of your study what is going on. For example, important to see is if you have already some differences in two-way travel time between your wells and your surface and the corresponding marker that is being auto computed by Petrel using the assigned TDR. So here we have already a list of differences in milliseconds, which tells you something about the quality of your interpretation, or if there might be differences in the time depth relationships. And you may want to look at these values and decide, for example, if in this case for well 6 you have 60 milliseconds difference, if this is acceptable for you or not. This may change in the different surfaces. No? So we also compute different other informations like velocities, average velocities, and also here we are displaying the seismic velocities, which you see they need to be calibrated. We have an anisotropy effect between seismic RMS velocities and well velocities. For this, it's one of the workflows can be done here. We can define a map of a calibration map based on searching radius around wells, and then understand, if you see here in gray, we're displaying the original seismic velocities. After applying the calibration, we have that the same, much closer to the well here in yellow now. So we can define certain methods to do the calibration. Another possible workflow is what we introduced in this new version 3, which is called the trending workflow, which allows you to the trend velocities based on the distance out of the trend. This is a very interesting approach, a statistical approach, which allows you to calculate interval velocities out of seismic RMS velocities, but using a statistical detrending approach. What I'm showing you here is already a scaled interval velocity map derived out of this detrended workflow, and we scaled it to the velocities of the well. So this interval velocity map you can use it later on in the velocity analysis step, which I'm displaying here now. And this is the core of the app. If you want, here is where you will spend most of the time looking at your velocities, understanding the behavior of the velocities for each of the layers. So it's highly interactive. So if you go, for example, and select and highlight one of the layers, here now I am mapping the velocities inside this layer here. So I will reduce the view, in this case, for example, to just a well and a few velocity locations. So to see, and I'm telling the system, I am mapping now interval velocity using wells and seismic velocities together in an integrated way. See, this is the interval velocity map I would get, but there is many options to do. I could say, I don't want to use the seismic data, I only want to use the well data, and you see the map changes accordingly. So then you can see what is going on here. There is like this doesn't look too geological in this well 14, and there might be some reasons for that. You see the data is a bit off. So you have to take or make a decision here. Is this correct? Is this wrong? So in one case, if you, like today, we don't have much time, you can say, I can mute that well only for this layer and see how this changes the map. So now this well is muted, it's not participating in the process, but I'm still getting all the values from the other wells to build my velocity map. So now this is a way more consistent map. So I can go back and, for example, map all these things together, and then I get a display of the velocities. Additionally, I have an estimate of my misties. So I'm already calculating the mistie values at that level, so I can have a mistie display. There is more options that we can do if, for example, here you see there is a linear increase, and that's what I've done. It's a defined linear increase with a constant K. So this is the classic V node K approach, and we have different possibilities to define different parameters on that. We could also say, for example, just a linear where also we map the K values. So this is a display of the K values. Or you say, no, we know K as a constant. So you have a constant value for K, and then you optimize based on the V node values. So this gives us this corresponding interval velocity map that you can display. So these are some of the options, but the point I wanted to make is that everything you do at this stage is displayed, and you get an immediate response from the system in terms of how your velocities are coming along, how they look like, and if they make a geological sense. This is something you need to do, because when you build a final velocity model, you need to be able to defend it at any time, especially during peer review meetings and also in front of the drillers or the modelers. In the next step, we look at the depth optimization, which means whatever we do in velocity model building, we will be dealing with something quite ugly, which is called residuals. Velocities are not unique, and all the approaches we take, they have several possible solutions. There's lots of uncertainty, but it's good to try to reduce the residuals. So this plot here, there's a cross plot between the corresponding elevation, therefore we are in the active layer, and the residuals. So the triangles are the residual values, and then we attempt to reduce those to close to zero. So we have the residual map, and then we have the optimized depth map. This is one approach. The other one is more sophisticated, where we update or do the correction of the residuals by adjusting the velocities. So we make the velocities faster or slower, if you want, during a mathematical approach, and minimize the reduction of this. Again, here you have the option to go tables with some highlighted values, warnings. If we especially go into areas where you are overstressing the approach, we warn you and say you might be overdoing the correction here. And then finally, once you have done all this step, there is lots of options to do outputs to create results. From velocity logs to points, to obviously do the depth conversion of your surfaces, and also the ability to create velocity velocity cubes that you can define any existing survey, seismic survey if you have as a container of this, and then you create your velocity model. Just to finish, in time, then we can have a look at the results now in depth. As I mentioned, I have this section here in Petrel, and then so you can display a lot of different results in velocities. So if you see, I have a set of depth converted surfaces already here. So I can, for example, start displaying the mid-tertiary here. This is one of the realizations I did. Using different parameters, you can get slightly different results. That would be the top chalk. All this is now, because it's optimized, changing the velocities is fitted with the markers. So you see all the depth converted surfaces here now. And here I will display also the velocity model as such. I created these cubes. In this case, you have, let's change the colors here in a second. Here you have the interval velocity, and here I have the corresponding average velocity map. Sorry, cube. It's a complete cube. So, and in terms of integration with the other processes of Petrel, in Petrel you have this simple velocity model. So it's very simple to just go and create your Petrel velocity model representation, which you need if you want, for example, to go for 3D grids and other aspects. Petrel will demand that you use their model representation for that, but that's very simply done. We use the output from our app, and you integrate it completely in Petrel, and this is a very simple step to do. So this is what I had. I think I'm still on time. So I hand over again to my colleague. So if there are some questions, we may have a few minutes to discuss about that.
Thank you, Gaston. As mentioned, if there are any questions, feel free to ask them now. If not, I'd like to thank you all for watching this seminar. Questions or any feedback, feel free to give us that and comment. And don't forget to register on the additional seminars coming up, webinars coming up, to the link below here. And as mentioned in the introduction, everything will be posted on our YouTube channel, and you will also receive an email link to this presentation.
There was one question I see here. There's the possibility to create different depth conversion scenarios. The answer is big yes. You can create as many independent depth conversion scenarios as you want. There is another question here about the possibility to convert them to points. Yes, you can convert that to points. Yes, that's also possible. Yep. I don't know if we have more questions to answer. But again, just feel free to send any question to us, either to our support channel or directly to me or whoever you know from Segal. Stoffel, you may want to close the meeting.
Yes, thank you very much, everyone, for attending, and look forward seeing or hearing from you soon. Thank you very much, and goodbye.